In this lecture, we'll be studying about operations on processes. And this lecture particularly will be about process creation. So let us see what is this process creation. So it says here, a process may create several new processes via a create process system called during the course of execution. So when we have been studying about processes from the last few lectures, we have seen that there is not only one process, but several processes that are running in the system. And all these processes are not created individually by the user or something like that, but a single process. It can create several new processes under it via a create process system call. Using this create process system call, one process can create so many sub-processes under it. And this can happen during the course of execution. So the creating process is called a parent process. And the new processes are called the children of that process. So as I told you, one process can create many other processes under it during the course of which execution. So the creating process is called the parent process. So the process that is creating the other processes, they are known as the parent process. And the new processes are called children of that process. So the processes that are created under the parent process, or the processes created by the parent process, are known as the children of that process. So from the name itself, it is easy to understand the creating processes. The parent process and the new processes are called the children of that process. Each of these new processes may in turn create other processes, forming a tree of processes. So we saw here that the parent process, they create children process. And those children process can also create children of their process and so on. It can continue. So each of these new processes may in turn create other processes, following a tree of processes. So we have the parent. The parent creates the children, and then the children create their children, and those children create their children. And it goes on. The formation of processes goes on, forming kind of a tree structure. So we'll be seeing that example by taking a diagram and trying to understand that. So here we have a figure, which is a tree of processes on a typical Solarist system. So as I told you, if you look at this, it looks like a tree structure. So let us try to visualize and try to understand what this tree means. Alright, so all these circles, or all these oval shapes over here, they represent particular processes. And they have a name. And they have a unique ID, which we call the process ID or PID. So each process is identified by their unique number, which is known as the PID, which is required. So we have already discussed that when we discussed about processes in the previous lecture. So let us see over here. So here in the beginning, we have a process called a shade or shed. And the process ID of this is 0. PID 0, so this is the parent process, or the first process that we have. And this shed process, it is creating 3 children, 1, 2, and 3. So these 3 are the children of this parent as shade. So what are the children that I see? They are in it with PID 1. They are paged out with PID 2, and FSV lush with PID 3. So these are 3 children created by the parent. A shade with PID 0. So this init process, it will serve as the parent for all the processes that will be created by the user. So if you look at this, the tree continues here in this way. And these are all processes that are created by the user. So this image process will serve as the parent for all this child processes created by the user. And this to page out, and this one, they serve as processes that take care of memory and file management. So for memory and file management, these 2 processes are created. So keep in mind this is on a typical Solarist system. Alright, so let's just continue from here and see what are this and what are the meaning of this processes over here. So we first saw that we have a parent here with 3 children. And now as I told you, this init process will serve as a parent for all the processes created by the user. So these are the processes that will be created by the users. So in it, over here it created 2 child processes in etd and dt login. So these are the children of init. And here we have inetted with process ID 140 and DT login with process ID 251. So this inetted process, it is responsible for the networking functions. So this process is for networking functions. And this DT login, it serves as the X window session for the user. So this DT login will serve as the login screen. It is a process that brings the login screen for the user. All right. So let's continue in this part, and then we will come back here and see what this means. So first of all, as I told you, IoniTD is the process responsible for networking functionalities like Telnet and FTP. And we see here, it created the Delinate process over here. So Delinate is started over here with process ID 776, and from here, it in turn created the CSH, which stands for the C shell. So it is a shell process over here. So using the shell process, the user can interact with the system. So it created the shell process with PID 777, and from here, the user started two processes. One is the Netscape browser, and then the Emacs editor. So Netscape is a browser, and the PID of this Netscape process is 7785, and also the user started. And Emacs editor. Emacs is an editor, like a text editor that we have, and the process ID of this process, this 8108. So these two are created or started from the C shell over here. So this is how the process tree continues, making children of their children. So we came from here, this was the child, and this has its child, and this is the child of this one, and this two are the children of this one. All right, now we come this side, and here, as I told you, DT login, it is responsible for the user login screen, and when this process runs, it provides an X window session for the user, and as I told you, the accession process is created the child of this DT login with process ID 4, and which in turn creates the STD shell process with BID 340, and here again, the C shell is opened right, which is the shell with PID 1400, and from this shell, the user can issue commands like lun, cat. So you are using our Linux-based system, you may know the meaning of ls and cat commands. Like for example, ls is used for listing all the files that are there in a particular directory or a folder. So ls and cat. So this kind of commands are there in Linux-based systems, and it is issued using the terminal, you may remember. So shell is also like that. From the shell, you can issue those commands, like lascat. Alright, so this lascat are subprocessors or children of this process, which is over here. And same way, this accession is the child of this duty login. STD shell, the child of accession, and C shell is the child of STD shell, and this two other children of this So this is how a typical tree of processes looks like on a Solaris system. Now, since we saw how processes are created, there are few things that we need to remember when a process creates a new process. Two possibilities exist in terms of execution. So let us see what are the two possibilities. So the first possibility is the parent continues to execute concurrently with its children, and the second possibility is the parent waits until some or all of its children have terminated. So when a process is created by another process, so we have the parent process and the child process, or the children process. All right. So when the execution takes place, it is possible that the parent continues to execute concurrently with its children. That means along with the execution of the children, the parent process also will be executing concurrently or under same time they are executing. That is what it means. Otherwise, the next possibility is the parent waits until some of its children have terminated. Or the next possibility is that the parent waits for its children process to complete some of its execution, and once the children have terminated, the parent will resume its execution. So even when resources are allocated, we know that processes are allocated certain resources. So let's say that there is a process with certain resources, and when that process creates its subprocess or its children, then the children may have all the resources that parent was having, or it may have a subset or a part of the resources that parent is having. So these are also two possibilities in terms of resource allocation. The children can have all of the resources from the parent or some of the resources from the parent. So depending on all those things, the parent can continue executing concurrently with his children, or the parent can wait until some of his children have terminated. All right. So in terms of address space, also there are two possibilities as above. There are also two possibilities in terms of address space of the new process. So let's see what they are. So first of all, the child process is a duplicate of the parent process. That means it has the same program and data as the parent. Or the second possibility is the child process has a new program loaded into it. So these are two possibilities in terms of address space of the new process that is created by the parent. So what are they? This possibility is the child is exactly the duplicate of the parent process. And what do you mean by duplicate? It means that it has the same program and data as the parent. So what is a process? First of all, a process is a program in execution. So the program will have the program to be executed and some of the data that is required. So in here it says that when the child is a duplicate of the parent, the child also has the same program and data as a parent. There is one possibility, and another possibility is the child process has a new program loaded into it. So in the second possibility, the child process can have a new program loaded into it, which is different from what the parent had. The parent may be running one program, and the child may be created in order to run another program, which is required by. So that is another possibility. So these are the two possibilities, each in terms of execution and in terms of address space of the new process. So these are some of the things that you need to remember about process creation. I hope with this you have a basic idea how processes are created. And this is an important topic under operations of processes. So I hope this was great. Thank you for watching and see you in the next one.